Hello friends, today I'll talk about event loop and related concept. Event loop, I am not going to explain the theoretically concept from beginning. I'll try to explain various why we reach to the event loop, and I'll touch upon few concepts like call stack and how you can dissect the call stack, how the function execution happen step by step. Then I'll talk about set timeout and various related concept and introduce this event loop at the end. But now let's get started. So for any JavaScript application, whether it is browser based or a Node.js application, as you are aware that it is single threaded. Other programming language, for example Java, is running in a multi-threaded environment. But Node.js is a single threaded application. Single threaded means it deals with the code what you are going to write by yourself. But the underlying framework is more complex. So actually the code what you are going to write, it is running in a single threaded environment. But whenever you call some operation, for example network call or file operation, that would be handed over to the kernel or operating system kernel, which is multi-threaded. Even though you use Java or any other programming language, so they eventually will hand over this actual execution of this code to the kernel, and kernel will convert to the machine code and try to execute it. And it has its own control how it can leverage this multi-core process, and it will spawn that actual execution. In case of Node.js, whenever we got request, our Node.js application will run in a single threaded environment, and any kind of non-blocking operation, for example HTTP request or file handling, that will hand over to kernel. And once the kernel completes the execution by means of its multi-threaded paradigm, it will put this result in some queue. And then this particular Node.js application will pick the message once it is available, the response, and process it. But before going to dive into detail, I'll show some code sample and try to simplify a bit step by step. So one important concept, if you are new to the computer science architecture, is like call stack or queue mechanism. This is a leaf of queue. There are two base queue. If you are standing in a queue to buy a movie ticket, then the first who stand in the queue, who will get the priority and he will buy the ticket first. That is how this the normal queue mechanism will work out. But this is a last LIFO queue. LIFO queue means whoever is the enter in the last, will be removed the first. For example, if you put A, so A will be keep on waiting. If there is a B, C, and there are a number of requests come in the beginning, so A will be blocked and waiting till the end. So whoever coming the last, he will be picked out. So the C will be removed, executed fast, even though it come into the end. So that is known as last in, fast out. So this is the approach. This JavaScript runtime, use it for the code execution. Let me explain what exactly it is related to the code. So we have a call stack LIFO queue, and here we have a simple code. This is a greeting function, and we should this is a function declaration, and here the first line we are doing this console.log some information, good morning, and it again called to another function, hi, and it also printed some more message. So if the interpreter or JavaScript runtime provided by Chrome will see this code, then how it will behave. And this is not a non-blocking request. There is no non-blocking code involved here. There is no callback here. This is a simple function. And this concept applicable to almost most of the programming language as well. So JavaScript also, follow the same call stack approach. So whenever it sees the code, so it will first put this greeting into the call stack. And once it start the call start getting execution, then it start to execute the code. Then it will go inside this code, Then it will encounter this call console.log function, and it will put into this call stack again. Here important thing is that it will try to execute it. If it will try to execute console.log, then because it is in my application code, I'm not going to inside this how it will represent inside the console.log, because console.log is also another function. So it may go inside and it will follow the same approach, but I'm not going to confuse you too much. So assume this is a atomic operation, or this is the exact function, and it will return some result. So JavaScript runtime will execute this code, and it will print this good morning at this stage, and it will remove from this particular call stack. So this good morning will be printed into the console, and it will remove this console.log from the queue. Then what will happen? This will be called this high again. This high. Once it will call to high, it will go inside this particular thing. Then it will try to put this console.log. If there is 100 console.log, it will try to put one by one. But if it's see atomic unit, like it will try to execute it. So this time at this moment, what will happen? It will try to execute this console.log as well, and print this high. Okay. Then once it will complete this console.log execution, even though the function nothing to do that, then there is nothing, no more entry here. So it will try to remove this from this entry, this high, and it will remove this greeting as well, because it needs to remove it so that it no need to wait and worry about like I have to do some more process. Then this call stack can be empty. If there is nothing is going on, there is no code to be executed, most of the time it will be empty, because you are watching, reading some books, reading some article into that thing in a web page, so nothing needs to be done by the runtime engine. It will call stack will create as empty. So till now it is a very simple concept to understand, but try to let me complicate it a little bit further. Here I have introduced a timeout, and it is the same function greeting. It will have same message and hi. So what should be the output? GM or timeout, then hi, right? Let me execute this code and show you this result. So I have introduced a timeout, right? I'll explain what happened in the background, but before that let me execute it. And this timeout is 0, so that means it should execute immediately. We should see this GM, timeout and high, right? So it will process sequentially one by one. Yeah, but there is slight surprise. It will first print GM, but it is not printing the timeout. It will print high. Then it is printing timeout. So this timeout is printing at the end. First it is executing this this function and this high console.log and timeout at the end. So this is a bit confusing to the beginner, but this is the desired behavior. So let me explain why it is happening in a call stack approach. So same here, like whenever we encounter greeting, so it will put as a greeting here. So good morning here. Then it will try to print the good morning, okay? And it will remove this from this particular message. It won't keep this good morning because it is an atomic operation. Nothing needs to be done there. It won't keep like this function we are still keeping, because the function execution is not completed. So greeting will still be there. But console log, once it is printed, nothing is there. So it will print that GM, remove out of it. Then it will put this, timeout part. Now interesting thing will happen. Because as I said, this won't get executed. Then what it will do? So to understand this concept is very important. So once it put, it will definitely put this set timeout because it is a set of expression. So it will definitely put this enter function call into this call stack or LIFO queue. But once it encounters set time, what exactly it will do? So what will happen? The JavaScript browser engine. So whenever it call stack, it will encounter the timeout. So it will keep and store into the memory. Okay. And there is a timer it will start because this timeout is operation is a timer operation. So it will start a timer. Timer is stopped now. It will start the timer. Now it is 0 I put, but even though you put like this is millisecond, 1000 second also. So it will keep this set timeout is memory, but it will start the timer. So 1000 means it will wait till 1000 millisecond or 1 second. When this timer stop, then it will put this particular callback function into a queue. And that queue is known as message queue. It won't put this enter function here. This is what is the message, like this console timeout. It will put into the message queue, not the call stack, okay? This is not the LIFO queue. This is like normal queue, whichever you put in the first, so it will be processed in the beginning. So maybe if you put message later, it is not a LIFO queue, okay? It is a normal queue, like movie ticket, you are standing in a queue. So whoever request come in the beginning, so he'll get the priority to be execution. Both queue looks same, but it is a slightly different queue, okay? Just to repeat again. So it called greeting, console.gm it printed, set timeout output, then JavaScript engine will, whenever it encounters set timeout, it will just try to see this timeout. But it won't block this process of this particular processing. So that will process in a separate process. If you keep on waiting this for 1000 seconds and it is, waiting here, and then only it will put to this timeout, then it will be gone case. You are not able to execute this high or any other message. So it is not going to store here and waiting till 1000 seconds to start the timer. So whenever it encounter this thing, it will start the timer, but it won't put this message, okay? So this message console.log will be kept in the memory. There are some different process which will store this timeout. So only when this 1000 timeout is elapsed, then only it will get this callback function, whatever this code is executed inside the block. It won't parse any message, it will just store into the message queue. So immediately when it encounter, it will start the timer. But only when this timer will keep track from memory or some other storage. So only when a 1000 time is elapsed, then it will put this message into this message queue. Okay, I hope you understood this timer concept. Now what will happen? But still this particular timeout won't get executed. It will be staying into the another message queue. So this call stack is important. So always JavaScript runtime will be only looking for this call stack. Even if there is one entry available, it is not going to read message queue. And because it is 0, so immediately the timer will start and put the message into this message queue. So because here we can see greeting is there and console.log timeout is there. But timeout is not getting the priority even though it is 0. So this JavaScript runtime is not going to look into message queue. So it will go into the next line, hi. So it will put hi. And then inside this hi it will go. So if it will execute this message, so it will put this console.log. So in case I'm just printing considered log, if you do a heavy processing like create a high while loop which run for like infinite loop, or you are iterating at 1 million loop, then even though it will take 10 minutes, it will wait till 10 minutes. Okay, so it is not going to see this message queue. So whichever the process, if you're doing one by one, so it will loop through this and process part this call stack queue. So once it encounter call stack, so it will print this hi message. So if it is a nested structure like hi equal to another function, then it will execute one by one everything in the call stack. There is another timeout, it will put another here. So this will be first priority, that will be second priority, but it is not going to read from the message queue at all. So remove this console log. Then this hi is printed, then it can remove this hi because nothing else to do. Just to keep track of that, I executed the method. Then it will remove this greeting. Then once it is completed and this call stack is empty, then this message queue will be put into this call stack again, LIFO queue. And this timeout will be executed. And this will be removed. Okay. So, and one more interesting thing. So till now I have not talked about like any event loop. So where is event loop coming into the picture? The event loop is nothing but which will keep on listening to this particular queue. Right? Let's say this is our event loop guy. So it will keep on checking this call stack is empty or not. Then it will keep on checking this message is there or not. There is a infinite loop. While loop is kind of, it is implemented as an infinite loop. It will keep on checking this call stack is empty. If not empty, then it will sleep idle. So it won't not going to do anything. Even though this message queue is increasing to around 1000 record. If let's say this call stack become empty, then immediately it will go and pick this message from here and put it into here. So this may not be a simple console.log. It may have some few lines of code. It will give the priority to this whatever the lines of code execution as per the previous approach. Then it will execute it. So this is what known as event loop. So loop will monitoring this call stack queue. If it is empty and there is some message into the message queue, so it will pick the message and put into this call stack queue. Now there is a, if you see this particular approach is not only applicable to timeout. This is applicable to most of this, web API or all the functionality provided by non-blocking API, because most of the JavaScript APIs which is provided by the browser engine. So this normal execution of function, variable, string, or normal, which is the normal code you can see that is run in the JavaScript runtime. But it is provided by Chrome V8 only. But that is there are two parts of JavaScript execution. One is exact JavaScript core, which is like variable, function, and that is engine. That will be executed in call stack most of the time. But there are some additional functions like timeout, click handlers, keyword events handler, or the DOM event, for example, onload, upload, like that, and fetch. So you're making some network request, or lots of API involved in Nodejs also, like file reading, writing. So those all will be, put into this message queue. So whatever the approach I have shown for the timeout, that would be this all message callback function would be stored into the message queue. So because there is a timer here, so in case of like fetch request, so the control will go to the kernel will make an internal TCP call or HTTP call to the network service. Once it gets response, then the data will come and put into the message queue. Then event loop will be processing that message. So those kind of network request and other async call I'll explain in some other video. but the concept is more or less same. But in the ES6 or ECMAScript 2015, if you remember, nowadays we are using promise, async, await. So for that, right, this concept is not directly applicable as it is. So for that, there is another queue introduced that is known as job queue. And it will process exactly same as the message queue, but only difference is that if you deals with promise and async await, this job queue will take this priority. So if you see, I'll show one example here. So if there is a timeout message lying in the message queue, and there is a promise or async await, you are approaching, you're doing some call and got some response. This is the timeout is present, and let's say this is from this promise. So for the promise in the ECMAScript ES6 or ES 2015, the job queue is introduced, and job queue is the priority because nowadays we are mostly relying on the network call to make some async await and kind of asynchronous call. So we don't want to wait indefinitely for this timeout queue approach. So whenever it will see this promise, so it will take priority. But even the job queue, it won't, even there is entry into this call stack, this won't get priority. So only if this call stack is empty, then first this event loop will read the message into the job queue, then process it. Once job queue is empty, then only it will go and process into message queue. Just to show that example. This is the example of job queue. See, we have same greeting method, good morning, and we have a timeout, and we have hi method. So we have seen this GM is printed first, then hi, followed by this timeout. Now once we introduce this promise, this is a new promise. Promise usually it is a slightly advanced concept. You may not be directly use day-to-day basis. So in most of the time you are using async or await. But under the hood, async await uses the same promise approach only. So async await is a syntactical sugar which will under the hood convert to the promise approach. So this promise, right, there is a callback function. One is resolve and reject. If it is successful, we can resolve it and we can pass a string here. Then to print it, we can call then and resolve it, and we are printing this console.log. So basically this promise will execute immediately, and it will print this console.log resolve. But the question is, immediately means when? Is it before this high or after high or before this timeout? So as I mentioned, this promise, there is another job queue is introduced. So first GM will be called, and even though there is a timeout is anyway waiting in the message queue, and when to call this one, is it before this high or after this high? As I said even though this is the promise message is there here, like promise call. It will be keep on waiting in the job queue. So if there is a call stack is high is there, because high will be executed in the call stack. So it will first print this high message. Then only it will go to the job queue. Now let's execute this code. See this good morning, this timeout not executed, and promise also not executed, then it executed high. After that promise executed, then timeout. If you see, this is the promise got the priority. before this timeout. And if you print little bit after this high method, so this end will be executed before this promise. GM high end, because this end is also part of this call stack. So once high will be removed from this call stack, then this console log end would be entered. So that will also get priority. And if you try to put this, some more console log into main entry point, I finish. This is also part of call stack. So this finish will be take the priority. See this finish. Then the promise call and the timeout. So even though let's say you put like promise in the end, promise called, right? So now what will happen? GM, then high, then end, then finish. After that, this is moved to the queue first in the job queue. So this promise call will happen. Then promise call 2, because this 2 also, this timeout we won't get priority. So this promise will get the priority, promise call 2, then the timeout. See this call stack and promise call 2, the timeout. So if you put like timeout, one more timeout, timeout 2. So this would be queued first, but all this timeout 1, timeout 2 will be executed after the promise. So timeout 2, right? That means this promise is part of job queue, which is introduced recently, and this will considerably applicable same to the await and async. And this listening from this particular queues is the event loop job. It will monitor this call stack. If it is empty, then it will go and read from this particular message queue and job queue. So this message queue and job queue is sometimes called as event queue, callback queue, or microtask queue. And there are so many terminology, but whichever terminology you use, you should be fine. As long as you understand the concept clearly, there is no problem. And this event queue is part of like C program. It's part of libev system. It is not part of your actual runtime. It is a standalone program. It is very lightweight. It won't do much of the. You can write the event loop by yourself. You can listen to the queue 0, then it will check this to queue and put the message. That's it. But understanding that which one is getting priority and how this call stack will work, that is more important than worrying too much about event loop. So in the next video, I'll explain about process streak and set immediate. That are a little bit slightly behave different way. So hope you understand today. Have a good day ahead. Bye bye.